Welcome to this lecture, where we will discuss a bit further about first and second generation feedstock and associated processes. Let's take a look at some examples, such as sugars from sugar beets and sugarcane, glucose sugars from cornstarch, and also hydrolysate from bagasse or straw, and from wood, such as in pulp and paper industry. We will not deal with oil crops, but it should be noted that the residual biomass co-produced with oil crops such as palm and soy also is a promising source of lignocellulosic material. Also, we will not deal with all details given the objective of this course, but it is important that you note that quality control of feedstock is expensive and require considerable investments. It should also be noted that most of the current processes are optimized, for instance, for pure consumption of sugars, and not for efficient production of a feedstock for further conversion. Producing sugar from beets starts with washing, slicing, and water extraction in a diffusion tower, with subsequent conditioning with lime and carbonate to remove impurities, followed by concentrating by evaporation and a cascade of crystallizers. This process is clearly optimized to produce crystal consumption sugar. As a fermentation feedstock, the limiting step may be replaced, thereby wasting less lime and also the capital and energy-intensive crystallization omitted. This results in drastically lower capex and opex. Production of sugar from sugarcane shows a comparable layout. The cane enters the plant in a cascade of 5 or more mills that crush the cane and simultaneously extract sugars in a counter-current manner. Note that this enormous machinery consumes roughly half of the energy use of a sugar mill and represents about half of the capital investment. The so-called juice is stabilized and clarified and subsequently concentrated by multi-effect evaporation. The concentrated juice is used for fermentation, often in combination with molasses, if part of the sugar is also crystallized, like in the example of sugar beets. It is clear that this process has clearly seen more optimization for use as a fermentation feedstock. Wet milling of corn is an even more complex biorefinery process that produces a range of products, like germ, oil, gluten, but also starch products. Starches are products on their own, but can also be hydrolyzed to produce glucose syrups. As glucose is a less sweet sugar than fructose, these streams are partially isomerized to fructose and marketed as high fructose corn syrup, which you typically find in your beverages. It is also clear here that there are more or many optimizations possible when these sugars serve as a fermentation feedstock. Can you indicate at least 5? Comparing to earlier sugar and starch production processes, you see now many similarities with the emerging lignocellulosic processes. Depending on the situation, they can be bolted on an existing biorefinery or fully dedicated to new crops, such as energy cane and others. For instance, in the case of sugarcane, the feedstocks can be bagasse that is already milled, so you can skip that step. But it requires pretreatment, hydrolysis, and subsequent fermentation and further downstream processing. There are also many opportunities to share facilities, such as steam, and thereby effectively reduce energy and water use. Lignocellulosic biomass can be obtained from many sources, classically categorized as primary and secondary biomass, either using croplands, grasslands, wood, and forestry biomass, or residues from agriculture, forestry, and nature. But remember that lignocellulosic biorefineries using biotechnological processes are just emerging, and that the first 2 only started operation in 2014 in Brazil and in the USA. On this world map, you can see the biotechnology plants using Generation 2 feedstock at TRL 8 and 9 in 2023, which are still only a few, but rising. Here you see the Sunliquid plant in Romania, which converts agricultural residues into cellulose and further into C5 and C6 sugars, which are both fermented to ethanol at the same time, allowing a higher ethanol production. The switch from first to second generation biomass ideally requires microbial hosts that are modified/adapted to consume more diverse sugars, and if possible also some of the organic acid byproducts of feedstock pre-processing. Here you see one of the second generation sugarcane cellulosic bioethanol plant of Raízen in Brazil. Raízen committed to building 20 new plants in the next decade, while Shell entered into a long-term agreement with Raízen to buy a total of 3.25 billion liters of sugarcane cellulosic ethanol in a bid to meet growing demand for sustainable fuels. Another example is a large plant built in India to convert rice straw to bioethanol. Summarizing, upstream processing is an integral and key element of the complete technology for bio-based products. It generally requires significant capital investment and is responsible for considerable energy and water consumption when not done right. In the next lectures, we will explore the third to fifth generation feedstock and bioprocesses. See you there!